finished for loops and we're ready to move on a bit. And after this point, we're hopefully going to move a little bit more quickly because we've introduced some of the basics. So I'm actually going to leave this code because it's a little bit helpful for getting the point of what we're doing next. So you may want to move Bob to another part of the canvas without actually leaving a trace. And you can do this by with the up command, which basically, again, imagine our little imaginary paintbrush on Bob the turtle. Imagine that Bob can kind of, maybe he's a robot turtle, can pull a lever and pick the paintbrush up, and he can move with the paintbrush up, so he's not leaving any trace. And then he wants to, he can put the paintbrush back down again and keep moving. So if you've called the up command, the paintbrush is up, and you can move, you can turn, you can do whatever you want with the paintbrush up, and it's not going to leave a mark until you do the down command again. So let's let's actually go 200, so, or 100, so you can see Bob draw the square and then kind of move past it. So you see Bob did the square, and then he just kept moving past without leaving any new traces. And we can kind of see, if you want to see just that code, leaving no marks at all, should work. And we just see just a blank line, but we know Bob starts in the middle of the canvas, so he was able to move this distance without leaving any marks. So that's what up does. Now, you might be a little bit bored of just drawing in black, fair enough. And luckily, we can change this with the pen color command. Oh, and just so you know, since we did Bob Dad down at the end of this, the pen is down again. So next time Bob moves, it's going to leave a trace. So just, remember, if you picked the pen up and you want to start drawing next, you're going to have to do the Bob Dad down. And this is an example of a case where a method doesn't take any arguments, but we do still absolutely need those parentheses, which I kind of mentioned at the beginning of part 1. All right, so pen color is the next method, and this one does take an argument, and that's the color. And so this here is an incomplete list of some of the colors that you can use. If you're interested to explore this color selection more fully, you can look into the documentation for this package. So let's say we want to do blue. Now, if we just run this code right here, we're not really going to see anything happen because we haven't moved. We changed the pen color to blue, but we haven't done anything to prove it. So pen color blue, and think for a second of something you want to draw. Maybe you just want to move forward. Maybe, I don't know, draw a square or something. So I'm going to go forward 100 pixels, gonna turn left 60 degrees, and then I'm going to go forward 50 pixels. Cool. It's gonna be in blue, and you can see this beautiful blue line. Maybe I've decided I'm sick of blue, so I'm gonna do light green. I'm gonna run. And so notice that these color names have to be in these single quotes. It's so that way it kind of recognizes it as a word called strings. If you just did if you did no quotes whatsoever, it would think it was a variable, which we're gonna explain as we move forward. So that won't work. You can see the autocomplete sometimes gets the best of what I'm trying to do. So yeah, there's changing the pen color. Feel free to mess around with that as you desire. And you may have figured this out, but you can change midway through your section of code. Now I want to go to magenta, and then I want to go 120 degrees left, and then I want to go forward 100 again. So I run this, and my first line is in green. I go forward 2 different segments, and then I turn left, and then I'm in magenta. Excellent. All right. So that's pen color. Pretty basic. And these are kind of the tools, we're just kind of building up a toolkit for you to be able to explore the subsequent exercises. So next up is pen size. As you've noticed, we've been doing a very thin line here. Pretty basic command. the default, if we haven't specified pen size in any of this previous code, so it just kind of assumes we want to use I think 1 pixel. And we can change that. We can use, it doesn't have to be an integer number. It can be a decimal, I guess. And so we can see, try and guess for yourself what this code is going to be drawing. First, if you want, it's kind of a fun exercise. And it's also fun to explore with these for loops a little bit, like changing the iteration to kind of see how, like, only going 2 times or 1 times to build up the drawing in your head and then understand how it's all coming together. And that's something you can play with on your own. Like for the square, for example, you could modify run it 3 times instead and see that it's only drawing 3 sides. It's kind of nice to convince yourself of how this works under the hood a little bit. I recommend that. But let's just, to get a sense of what this is doing, let's just run this code and see what happens. So it's a triangle, which you may have guessed. And we can see this, if we only do this once, we draw one side, and then we turn right 120, which brings us all the way around here. Then we go another side and we turn right 120, and then we do one more time and then turn right 120. And so yeah, and then you get these inner angles of 60 degrees, so you get 180 total, which a triangle has to have, probably. Yeah, and so you've noticed that at the end of this code, we do up, and then we move forward to a totally different part of the canvas, and we go down. And so you can mess with this pen size here. Let's make this triangle a little bit bigger so that we can see this a little more clearly, and say we do 3.5, then we run this. We can see that it's nice and thick. Yeah. So you can do more things than just go forward and turn. For example, you can draw a circle. So let's, again, just kind of run this, see what happens. Actually, I'm gonna leave this so that we can see an example of, drawing things on different parts of the canvas. And so let's just run this as is and see what happens. So Bob draws, and Bob goes to another place in the canvas, and then Bob draws this nice little circle. So how the circle method works is the argument, the number that you're passing into these parentheses, is the radius of the circle. So take a second, change this code to draw a circle with a radius of 50 in the same place if you want. Yep, pretty easy. We're just going to change this 20 to a 50. We run it again, and look, we have a nice big circle. Excellent. Okay, so one thing we can do, and now I am going to comment out all this other stuff here, and now we're going to mess around with the speed. And as I mentioned a little bit earlier, sometimes it's hard to, see the clear progression of how Bob is drawing things because they all kind of appear to be happening all at once. But you can actually change the speed at which Bob draws. So let's run this code here and then get a sense for what's going on. So we see Bob draw us a circle. I'm going to make that bigger because it looks really tiny on my screen here. So as you may have noticed, this is way slower than what we saw before. So we're actually setting the speed here. If we do 0, it's actually the fastest, and that's kind of instantaneously. And that's, I guess, the default. When we didn't specify before, it did look like things were happening instantaneously. If we do, and then otherwise, if we go back to 1, it just kind of increases from 1 to 10. So if we do 5, we can see it happens faster. And then 10 is the fastest without actually being, instantaneous, without just kind of like magically appearing like it does on 0. So I would recommend going back to some of our other for loops, especially, and changing the speed beforehand to kind of, it's nice to see it happen one step at a time, one segment at a time. And similarly to how you can change color midway through, how you can change pid size midway through, you can, let's say we started with the speed of 1, and then we decided we wanted to draw faster next time, and we've moved forward to another part of the canvas, and we've put our pen back down with this already written code, and then maybe we want to draw another circle, this time with a radius of 10, and we're drawing it faster than last time. So you can see we draw our nice big circle real slow, we move, and then we draw one way quicker. So yeah, and then that's speed, all there really is to it. And then for any subsequent code, since we've set it at speed, it's going to run that at speed 5 unless we change that. Well, not since we've commented it out, it's not, but hypothetically it would. And then, you know, all we've been drawing so far are curves and line segments. You can also just draw a single dot. And an important thing to note here is that this command works even if the pen is up. So for going forward, for backward, for the other commands, you have to have pen down to successfully make any mark on the canvas, but dot is something you can successfully leave a mark with even if you've done pen up. So let's run this code. Let's just see what happens. So I've gotten rid of the other stuff, and Bob leaves a nice little dot. And so you'll see that they kind of appear to be, this is a for loop. It's supposed to do something 5 times, but since Bob isn't moving in between, we only see 1 dot. So take a second and think for yourself, how are you going to fix this? How are you going to execute dots are spread out and they're not connected by any lines? Pause the video if you need to, if you haven't figured it out. It's really valuable to figure things out by yourself first. It's the best way to learn. But if you have, you've come back from pausing, I'm going to go through the solution. So the important thing to remember here is that we can draw dots even if the pen is up. So the easiest thing to do here is just even before we get into the loop is to pick our pen up. And so now we want to draw 5 spread out lines. So it's up, but we know we can still draw a dot. And then we can go forward, and we're not going to be making any marks with the forward command since the pen is up. Let's go forward 20. And then this is in the indent, so this is going to happen 5 times. And then at the end, we do Bob dot down as kind of standard practice. This is a little bit redundant in this case since we pick the pen right back up again to then go backward and then bring it down. So we could really get rid of this line and this line, and it would do the same thing. So let's run this and let's see what happens. So now we get our cute little 5 spread out dots. And kind of as I talked about, it can be helpful to set the speed so you can see this actually happening slowly. And now we can see Bob drawing those, and then you can mess around. What if you only want 3 dots? Now you get those 3, it's still pretty fast. Yeah, so he makes his dot 1, moves forward, dot 2, moves forward, dot 3, moves forward, and then he backtracks, all with the pen down, but dots can still happen with the pen down, as we talked about. Okay, so that's dot. And the next exercise we're going to do is drawing a star. This is pretty, you just kind of have to know that these are the angles you need to add up to successfully get a star. Just a fun experiment. You can mess around with other angles, other side lengths to get different shapes. But let's just run this and see what happens. There we go. We get our beautiful star. So you can mess around yourself. What happens if we change this angle? Like what happens if we make this 164? Looks a little funky. So yeah, geometrically, you kind of need certain things to work out, but we can definitely change this to say 100. And since we still have that 144, it still creates a nice star, but it's just bigger this time. And again, in any of these exercises, it's you can mess around with the speed. You could mess around with the color, the pen size. Yeah, definitely use this as an opportunity to get used to some of these commands as well. Feel free to pause the video at any time and experiment. Highly encourage that. You don't have to have just one turtle on the screen at a time. You can have multiple bobbing around doing their thing, drawing. And so in this line of code, we're creating another turtle. And we're naming it Polygon because we can. You could have it be Jane. You could have it be, I don't know, Strawberry. It doesn't really matter. Just don't name it Turtle because that can cause some issues because that's the name of the package. And don't call it Bob because if they're the same thing, you're only really going to get one turtle. So we have a totally new turtle. It's called Polygon, and it's going to start at the center of the screen. And so I'm actually, let me leave this star code back up so you can see that Polygon is going to be independent from Bob. So if we run this now, actually, well, all right, I should do I'm going to turn Bob around and put him to a different location of the screen so you can see that Polygon is separate. So let's have him go up and then just kind of get away from everyone else. It gave an error because I started editing while I was still trying to execute my code. That's my bad. So Bob draws this and goes up, and then after Bob goes away from the star he just drew, we create a new turtle called Polygon, and it's in the center of the screen. And we can, let's have Polygon draw a line down on the screen just towards the bottom of the canvas. So we're going to call it Polygon. This time we're telling Polygon to do things. And we can go, we're going to turn right 90, and then we want to go down, not down, sorry, that's the direction, but the command is forward, 100. And then, yeah, so they're doing their own thing. And then, I mean, we could have Bob go forward 20, and that's not going to change anything that Polygon is doing. They're their own turtles. And so, you know, we can also do things like, if you remember, we have the option to do pen color, and we could have our turtles be in totally different pen colors, and that'll work. So maybe we'll do bob.pencolor magenta, and then we've created Polygon, and then we want to do polygon.color light green. Guess I'm not creative enough to think of more than 2 colors. That's okay. So Bob draws in magenta and Polygon draws in light green. Definitely feel free to mess around with this. You can create more than 2 turtles. Just make sure they have different names and that none of those names are turtle. Okay, so the last thing we're going to talk about is variables. And so we've actually been using variables in this already. Bob is a variable, Polygon is a variable. And let me kind of explain exactly what that is. So to kind of get into what exactly variables are, we're going to start with a use case for why we even have variables. So this code here is referencing Polygon, and I had commented out my first creation of Polygon. Oops, that's the wrong line of code. So let me just bring that back in here. And now that error will go away. So let's kind of just run this and see what happens. So we've created this beautiful pentagon. And let's say that we wanted to draw a bunch of pentagons. Maybe, you know, we wanted Bob to also draw a pentagon. So maybe we wanted to do this right afterward. Maybe we wanted to have Bob draw the pentagon instead. And so let's maybe start with, let's move Bob to a slightly different part of the canvas. then polygon, so that we can create two distinct polygons, and then turn them to face the same way so they look nice and symmetric. And let's say that we always want, I forgot about this, the polygons, the pentagons that Polygon and Bob are drawing to be the same size. So we do this. That didn't, oh, for some reason. Oh, because I did not call Bob that down. Told you all that was super important, and I didn't do it myself. Clearly, I did not go far enough. Whatever, that's beside the point. Didn't really think that one through. But let's say that we always want them to be the same size as each other. Maybe we like this pretty overlap. And let's say we decide that instead of drawing, so this is 70 pixels right now. And let's say we decided we wanted them to be 50 pixels. So we've actually done this so that we're referring to a variable. If we didn't have the variable here, if we wanted to change the side length, we'd have to make this 50 and we'd have to make this 50. And then we'd have to run it. And now we have this new side. And oh my gosh, what if we change our mind again? And we're like, actually, I want this to be 40, but I also want this to be 40. And you can see how, maybe in a more complex code, you're referencing the same number a bunch of different times. And if you change your mind about what that number should be, it's a massive pain to go back through and find all those instances where you use that number, where you need it to be the same. And it can be a big source of errors. So what's better to do here is to create a variable that is assigned to that value you want. So we've said here that we want side length to be equal to 70. And then so when we call these methods and we pass side length as an argument, we're just referring to this number. Basically, the the compiler that's translating our code into something the computer can read, and then running that code translates this to be, oh, I'm going to look inside this little box labeled side length, essentially, and I'm going to see that it holds the number 70 in a sense. And so I'm going to go forward an amount of 70. And then so since we're using this variable in the same place, if we want to have both of our pentagons be of side length 50 instead, we only have to change it up here because these are both referencing the same variable. So now when we do it, so we can see that, and then we could see if we wanted to make them bigger with 70, then they get bigger. And similarly, these are all variables. So if we wanted to only do 4 sides of a polygon, of a pentagon for some reason, we could do that. Or you mean the more practical application of this is to say we want 4 sides, and this is structured in such a way that 360 divided by this gives us an angle. So if we change this to 4, this is going to change to 360 divided by 4 equals 90, and then we're going to be drawing squares with side 70 because this the for loop variable takes num sides, so it's going to iterate 4 times. So now Bob and Polygon are each drawing squares with side length 70. And so, again, this variable usage is useful here because when we set num size equal to 4, instead of having to, recalculate this ourselves to figure out how big the angle should be each time, we know that we want the angle to be 360 divided by the number of sides, and we don't have to update this number ourselves. We only have to update num sides to properly fix angle. So that's where variables are useful. And again, Bob and Polygon are themselves variables. They're, when we say Bob, when we say Polygon, the computer is kind of like looking inside that name and saying, oh, hey, this is this specific turtle object that knows all of these methods. The computer itself it doesn't use the names Bob and Polygon. It just uses the important data associated with the names Bob and Polygon. And similarly, the compiler, when it breaks down your code into something the machine can read. Num sides isn't written there as a word anywhere. But the information stored there is the important thing that gets accessed every time you refer to num sides or any other variable. Okay, so that's everything. One last final thing. It's always nice to kind of clean up your code at the end by saying turtle.done. You finish drawing with your turtles, kind of like put it into sleep. It just tidies everything up so you have no loose ends, nothing weird can happen to your code. And so as I mentioned, in the repository you forked, there are some other fun exercises that you are welcome to do, and I highly encourage you to do that have instructions in, so you should be able to work out by yourself, what you're supposed to do. And then, so that's graphics colorful hexagon.py and graphics random flowers.py. Full of challenges. And then there's also this basic template, which has, a reminder that you need these basic lines. You need to import the package. You need to create at least one turtle. Again, you don't have to call it Bob. You have perfect free will. Just don't call it turtle. You can do whatever you want. Feel free to look through that documentation I talked about for the package and experiment with some of those methods. And then just say you're done at the end. So that is everything for Python graphics. I hope you enjoyed these videos. Thanks for watching, and good luck completing the exercises on your own.